Linear momentum. The linear momentum is defined as the mass of a given object times its velocity. The momentum is a vector quantity, and it is at all times pointing in the same direction as the velocity. P equals mass times velocity. The momentum P and the velocity are collinear. The SI unit for the momentum is kilograms times meters per second. You can easily derive it from the expression. The mass has a unit of kilograms and the velocity a unit of meters per second. Recently, we have introduced Newton's second law in the following form. The net force equals mass times acceleration. As you know, the acceleration is the change in velocity over time. Therefore, this expression can be written down as the F net, the net force, equals mass times change in velocity over change in time. Notice that the expression in the numerator is mass times delta V. That is the change in momentum. Since the momentum P equals mass times velocity, therefore the change in momentum delta P must equal the mass times the change in velocity delta V. The mass does not change, it's only the velocity that is going to change. Substituting the mass times delta V in our main expression, we obtain the net force to equal the change in momentum, that is the m times delta V, divided by the change in time. In the case where the net force is not constant, this expression can be written down as follows. The average force equals the change in momentum over the change in time. This expression is very useful, and we are going to use it to introduce the conservation of momentum, particularly in situations where an object experiences an explosion or multiple objects experiencing collisions. The change in momentum delta P in those cases is always the difference between the total momentum of the system before and after the event. The change in time delta T represents the time it takes for the event to complete, which is very short time. The impulse. The impulse is defined as the force acting on a given object times the time delta t during which the force acts. In fact, this is the change in momentum. You can easily predict it from the units. The force, newtons times delta t, which is seconds, that's kilograms meters per second. In the previous slide, we have introduced Newton's second law in the following form. The average force equals the change in momentum over change in time. If you multiply both sides of this equation by delta t, you will be able to cancel the delta t from the right hand side. And now you can express the delta p, which is the change in momentum, in terms of average force and the time delta t. As I said earlier, the change in momentum indeed is the impulse, which is equal to the average force times the change in time delta t. Graphically, the impulse is represented by the area under the curve for a force versus time graph, which is the area under this curve here for the baseball bat example.